Hi everyone. Hello. My name is Christian Seltzer. I'm the president of the Convergence Initiative, and I'm extremely happy today to see all of you here. I have two brief announcements, words to say before to start. So the first one is we have today a fantastic tour to the technology platforms of the Research Institute of the McGill University Health Centre. We are part of a collaboration with the BRAIN program and with the School of Fine Arts of Concordia University. And what we are trying to do is put neuroscience and arts together to make, through this communication, create new ways to bring not just art and science, but what is new from both of them to the public. So we are really happy today to be hosted by Patrice and by all the people that was part of the platforms, and for all the work that Marie in particular did to organize this event here. And we want to give thanks for that. So we want to give thanks also for the collaboration that is happening, for the students being here today. So that's the first thing. The other thing I want to mention also is that today this is the second part of the event. This is what we call the black box, because it's directed mostly to what happened in our brains. So that's why we call it like that. We have another event that's called the white box, where we go more in the arts part of our collaboration. But today we will talk a little bit more about the brain. And for that we have a fantastic guest today, who is Stefanie Blain-Moraes, who is a professor in McGill from the School of Physical and Occupational Therapy of McGill University. And she's also a neuroscientist from the Brain Repair and Integrative Neuroscience program, the BRAIN program of the Research Institute of the McGill University Health Centre. Now, I could be in here speaking for a long time about all the titles and all the awards that Stefanie has, but what I want to do really is focus on one particular thing, and is in the meaningful work that she do to improve the life and the quality of life and communication of patients and people that have patients that are not able to communicate easily, people that is in coma, or people that is in a vegetative state, or people that have autism. So the research that she do is precisely to bridge these barriers of communication with these families that so much need to know how their family members are. What is fantastic of all this work is that she has done precisely that bridge between science and art, and this is why we are so happy today to have her here. And I will not say any more, because I think she has plenty to say, and it's fantastic talk. So please let me welcome Stefanie Blain-Moraes.
Thank you, Christian, for that lovely introduction. It's a pleasure to have the opportunity to speak to everyone today. Before I start, there was one person that was left out of that thank you. Christian just did so much great work putting this together. I was of zero help putting together any of this. I was on maternity leave for the past 5 months. I haven't been responding to emails. He asked me for titles, abstract. I gave him nothing. He pulled this all out of thin air. So thank you, Christian, for being able to work with me and make this happen. So I have a large research program, and it covers everything that Christian talked about, but today what I wanted to do at this particular event was to highlight one of the technologies that I'm working on developing in my lab called BioMusic. And I wanted to highlight this because it's one of the good examples of how science can create art and how art informs science in the technology itself, but I also wanted to talk about the process of creation, because in the process of creation, we moved between science and art quite a few times, often serendipitously. And I wanted to take everyone in the room sort of through the process of creating this technology, just to see how those two seemingly disparate threads interwoven in its creation. So the technology began when I was doing my PhD at the University of Toronto. I worked at a children's rehabilitation hospital called Bloorview Kids Rehab, and I ended up volunteering for 5 years on the complex continuing care unit at Bloorview. This unit housed about 17 children with very complex disabilities. The technical term is profound multiple disabilities. And when I talk about this group of individuals, it's difficult sometimes to paint a picture of what their lives are like for people who haven't interacted with such children before. So I'll do my best. It's important to be able to try enter their world to understand why the technology developed the way it did. This up here on the left, that's a picture of Bloorview Kids Rehab. And on the right, we have a picture of a typical kids' room at Bloorview. They live here because they are so medically complex that they cannot go home. Many of the families want them home, but they just need 24-hour care, personal care, and they tend to be fully reliant on technology. What do I mean by that? So here's an example of one of the children with complex continuing care. There's a lot of things that are needed to feed him. He's fed through a G-tube in his stomach. Most of these children are on respirators in order to breathe. They're monitored all the time. They have medical emergencies quite often, and so they get wheeled out of their rooms fairly frequently. So I want to paint a picture of a child who's fairly fragile, medically complex, very technology dependent. And most of the time, they have very little ability to move, very little ability to speak. So the circumstances behind this condition are very varied. They could have an injury at birth. They could have had a traumatic brain injury later in life. They could have a neurodegenerative condition. But we end up in this situation where there's very little communicative ability, either by verbal speech or even through augmentative and alternative communication, where you can push a switch to indicate yes or no. Even that, these children have trouble with. So when I looked at these children as I was volunteering with them and as I was working through my PhD, I said, so their somatic nervous system is shot. The nervous system that controls their ability to voluntarily control their muscles, that's shot. So what if we were to tap into a different nervous system? What if we were to tap into their autonomic nervous system? So this is an illustration made by one of my BioMusic co-designers. I'm going to get into this later in the program, but we work with individuals who will eventually use BioMusic. And I do a lot of explaining of what the autonomic nervous system is with, very complex slides. And one of my collaborators said, no, that's very not intelligible. I'm going to draw you a picture about what the autonomic nervous system looks like so you can explain it to other people properly. So this is Alex's rendering of the autonomic nervous system. It's the nervous system in your body that's responsible for either putting you in a fight or flight mode or a rest and digest mode. So your sympathetic nervous system sort of fires you up in very broad terms, and your parasympathetic system tends to cool you down. What these two nervous systems control in concert with each other are things like your dilation of your pupils, the amount of sweat in your skin, whether your digestive system is on or not, your heartbeat, your skin temperature, those sorts of things. And my hypothesis was that if the somatic nervous system was offline, perhaps we could enter these children's world using the autonomic nervous system. What if we were to listen to their hearts? What if we were to figure out when they had sweaty palms? What if we were to figure out whether their breath was short and quick or long and slow? Maybe we'd be able to figure out something about their worlds by listening to that part of their body. So here's an example. I'm an engineer. I have to put graphs up onto my presentations. Here's an example of what these signals look like. You're looking at the electrodermal activity at the top, which is a measure of the amount of sweat in your skin, respiration, and heart rate over here. And I'm putting this slide up for two reasons. One is to be able to show you that the signals are fairly slow. They're not like what we collect in the brain. They don't change on millisecond levels. They're fairly slow. They change over the course of seconds. And the other thing is to be able to show you that what's important about these signals are not the raw signals themselves. We really get very little information from the absolute values, the baseline values of these signals. My skin temperature could be at a certain level, your skin temperature could be 4 degrees higher, but that does not necessarily mean that you are happy and I am sad, for example. What we do is we extract features that we know are related to emotional stimulation. So take, for example, the electrodermal activity. These spikes that you see here, 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 and here, these are called electrodermal reactions. And these are what were originally recorded in the polygraph tests of the 1970s. When you would tell a lie, you would see the pen spike, and that was an electrodermal reaction. So it's a measure of autonomic arousal. Those electrodermal reactions are what I call a feature of the electrodermal activity, and it's the features of the signals that something is interesting in. So, for example, you can take a look at the respiration. A feature of the respiration would be the amplitude, the height of a breath. If I'm taking a deep breath, I have a large amplitude of this signal, how fast it is. My heart rate, I can look at how quickly things cycle. And I can also look at features that are correlated between the different signals. So a very interesting feature is whether, you'll notice that the respiration and the heart rate, they look sort of correlated. This happens when you're relaxed. There's a natural process in your body. When you take a deep breath in, your heart rate does a slight acceleration. When you exhale, your heart rate does this slight deceleration. And you can really see it quite clearly on this graph that there's a correlation between the heart rate and the respiration. That correlation exists strongly when an individual is relaxed, and it tends to decorrelate when an individual is not relaxed. On top of all of that, I can look at the correlation between the heart rate and the respiration and tell you whether these electrodermal reactions are meaningfully generated by something that has caught my attention, or whether it was just an internal process that generated the electrodermal reaction. So the point I'm trying to make here is that it's not the baseline features of the autonomic nervous system that are interesting. It's not the baseline values. It's the features of these that matter. And my hypothesis was, okay, we just need to find the right set of features that are associated with different states, and we'll be able to figure out whether these individuals who cannot communicate are excited, whether they're calm. Maybe we can even get to a point where we're distinguishing emotions. So I recorded, as most of us do, I started off with healthy, able-bodied subjects, and immediately ran into problems. So this is a graph from a study that I did with 9 nurses, so healthy, able-bodied nurses on the unit, and I presented them with a stimulating a target, something that they could report that they were getting excited by. And I looked at how their bodies responded to something that they self-reported excited them. So these are the 9 participants across here. I didn't list exactly what the technical feature was, but here's all the features listed down in the rows. And if you look across, there's not a single person who responds the same way to an exciting feature as someone else does. Now, this is not too, if you step back and think about it, shouldn't be too surprising. My body is different than your body, and I have my own idiosyncratic way of responding to the world. But looking at this graph, I was struck with how different, how large the inter-individual differences in the way that we respond to this world are. In the case of people who can communicate, I can say, okay, was this stimulating for you? How did you feel? And then I could start doing a mapping between your particular body responses and what you're telling me you're feeling. But I was stuck with my target population of people who couldn't communicate. If I saw changes, I would have no idea whether this was just the autonomic nervous system maintaining homeostasis as it's supposed to do, or whether this was a meaningful response to a stimuli. So at this point, I really was quite stuck in my graduate studies. I had no idea how to move forward from here. And serendipitously, around this same time, 2 practitioners from the unit below came up to the research floor and started asking questions. These 2 practitioners were therapeutic clowns from the complex continuing care unit, who have a mandate in the hospital to be able to empower children to make choices in an environment where they have very little choice most of the time. One of the things that they really wanted to be able to give the children was the power to send them away. You know, if they didn't want to see the clown, this was probably one of the only people in the hospital that the children could say, no, I don't want you in my room. They had no other choice with a lot of other people. So they wanted to be able to make sure that they weren't coming in when they were uninvited, and they also wanted to make sure that they weren't invoking harm. You notice that these are not your circus clowns. They don't have white makeup. They don't have big, frilly, colorful wigs. They have costumes, but really the only gesture to the fact that they're clowns are the red noses. And yet, we know that a lot of people have a fear of clowns. So they were worried that if they came into the room and started interacting with the children, with a child who couldn't speak, they would be interacting with someone who was afraid of them and causing harm without knowing it. So they came up to the research floor and started saying, so, is anyone around who can tell us whether these children who can't move and speak are feeling afraid of us? I said, well, actually, I am struggling with the exact same problem. Maybe we can work together. Maybe we can solve each other's problems. So with the clowns, I found myself a stimulus, so to speak, that would excite children. And at the same time, they gave me the ability to do a within-subject design of my studies. Instead of comparing these children to people who could self-report or to children who had fairly typical autonomic systems, I could create a situation where we had a baseline state, a very stimulating interaction, and then a follow-up, and compare the children to themselves. So this is what I did. I ended up creating feature graphs. This is a three-dimensional representation of those, for example, 8 features that I showed you before. I plotted what their baseline state was, did a bunch of transformations, looked at what we would expect a baseline autonomic activity of that particular individual would be, and then I plotted what that state looked like when the individuals were interacting with the clowns, which are these red dots over here. And when I was working with the data, I was super excited with what I was seeing. The clowns were causing the individual's autonomic nervous system to react in ways that were not as a result of the visual or the auditory stimulation, because we had a control experiment where they would watch TV, where they had visual and auditory stimulation. It was something to do with the interaction that was causing very strong, very distinct reactions in their autonomic system that was pulling it far out of baseline. And then when the clowns would go away, the systems would return back to baseline. And what this meant was that the children were perceiving the presence of the clowns and were reacting to their interaction. This was super exciting to us because these kids, some of them were considered to be in vegetative state. Some of them, the clowns would say, well, we interacted with them, but they were sleeping the whole time. They didn't know we were there. And we had evidence for the first time that they were reacting to their environment. And this is a big deal. But I couldn't communicate this. My graphs, this is a 3-dimensional version of the graph. I had an 8-dimensional graph. And I would show it to the caregivers, and I would show it to my collaborators and say, look, they're reacting. And I would get blank stares. I would get, oh, that's nice. And the conclusion here that non-communicative children have distinct physiological responses to interactions was being completely masked by the medium that I was using to present the data. So I took a step back and said, okay, we need to find a way of being able to communicate this data in a way that is intuitive, that can be grasped without without a lot of scientific training. You don't need to be an engineer to be able to understand what's going on. And I turned to another set of my training. I'm trained as a classical musician. I play the piano. I dabbled in other instruments as well. And I thought, well, when we listen to classical music, we receive multiple streams of information simultaneously, and we're able to process them all. What if we turned all of this information into music? So the BioMusic was born as a solution to this particular problem that we were facing with the data. So as an initial test, what we did was we ended up just mapping it according to classical music tropes. So the heart rate drove the tempo of the music. When you had a big spike in the amount of sweat in your skin, you heard a in the melody. If you had a significant change in your skin temperature, we would change the key of the piece. I'm such a classical trained musician. We went through a cycle of fifths, so from C major to G major to D major, et cetera, so that it would sound pretty when it was changing the key. And we said, well, does this work better than visual? So I wanted to show you a video of one of the very first prototypes of BioMusic. This is my colleague, Elaine Bittis. And she's wearing on her hands, she's wearing 4 sensors that are picking up her autonomic nervous system signals. I'm going to play the video for you, but the video is really just to show you that she's not moving. She's not doing anything that will influence the music. It's all in her head. And so at the beginning of the video, my instructions aren't so clear. I say to her, think of something that will relax you. And then halfway through the video, you'll hear me speak again, and my words are, now think of something that will stress you out. And she's reported afterwards that she thought of a grant that was due the next week. And so this is our first prototype of BioMusic and our test to see whether we could hear what was going on inside her body. Something that's going to stress you out. So that seemed promising. It seemed like there was a change pre-post. And we thought, okay, it works with us. We started playing games in the lab. I would give the biomusic sensors to my fellow graduate students. I would turn my back on the room, and people would randomly put it on, and we'd guess who was wearing. I hear that cycle. That must be Natasha. And okay, that sounds really, really slow. It must be Jorge. And we'd play games about guessing who was wearing the sensors. And we started noticing that biomusic could pick up really sensitive inter-individual differences. So we ran a pilot study at Bloorview Kids Rehab looking at whether biomusic affected the way that caregivers perceived these silent individuals. Our research question was, how does biomusic affect the caregiver perceptions of their interactions with persons with profound multiple disabilities? We recruited 3 children from complex continuing care with various degrees of communication. At the very low end, one had really nothing, no interaction with the environment. At the higher end, our participant was able to sometimes smile, and she had a little bit of muscle tension in her shoulder when she didn't like something. And we recruited 10 of their caregivers, which varied from parent to nurses to therapeutic recreationists and artists who normally interacted with them. And we asked them to come in and interact with these individuals as they normally would. Interspersed with a bunch of interviews, we had 4 biomusic sessions. They came in, whatever they normally did with these individuals, they continued to do, but we played biomusic in the background. And this biomusic was being generated in real time by these so-called silent children in response to what the caregivers were doing. So what did we find? The first thing was that the caregivers noticed that the biomusic would change if they did something. So a nurse would be coming up to the patient, they would hear a change in the music based on the fact that they were approaching the patient. And because they heard changes in the music, this changed the way that they interacted with these children. One of the caregivers in the final interview said that biomusic has a big role on myself, knowing how to deal with him. It calms me down. Instead of being so silent, there's something right there. But the thing that really, really excited me was that we had a number of caregivers who reported that having the biomusic there, and keep in mind, this was only 4 10-minute sessions, so they're very, very short exposure to this. Having the biomusic there changed the caregiver perception of the non-communicative patient. So this is a quote from a father whose son was in a traumatic accident 3 months prior to this experiment, and who, for all intents and purposes was considered to be in a vegetative state, he reported that the sound keeps on. It feels like my son still exists. And this is a quote from a nurse who had been taking care of one of these patients for about 10 years on the complex continuing care unit. It's a long quote, but it's worth reading. She said, "It's almost like she was trying to relate to you through her music, to us. But I'm thinking that was unique. Like we forget as caregivers that, we just kind of not look at the person and just do what we have to do. This makes us step back and actually think about, okay, so this is a person. She may be dreaming, she may be having some sort of thought she's not able to verbalize, but there are other ways she could probably give back to us." So when the results of this study wrapped up, we knew that we were onto something. We knew that we had something that was somewhere between science and art that was able to create these potentially profound impacts in the lives of these children. I had to take a 5-year hiatus from BioMusic when I went down to the States to do my postdoc, but I came to McGill in 2016 and established the Biosignal Interaction and Personhood Technology Lab here at the School of Physical and Occupational Therapy. And we have been actively developing BioMusic ever since. So there's a lot of really cool stuff going on with this technology. We're developing the hardware instead of having sensors all over. We're down to one sensor. We're actively working with a company here in Montreal to turn it into something even less intrusive, just a ring that you wear on your finger. We've got some really cool developments that are going on with the software. We have a lot of machine learning expertise in the lab right now who are trying to train the software to recognize specific states of emotions that are specific to one individual. But I'm happy to talk about all of these developments after. But what I wanted to focus on here for this talk was the relationship between the ways that the technology are developing and the art that it can create, and how that art in turn informs the science. So I'm taking a very, very narrow view right now of how this technology is moving forward. So the first example of how the science and the art interact that I want to present to you came from. Actually, I'm going to blank the screen for a second. Came from, because when there's words up there, you look at that instead of me. It came from a workshop that we ran in Montreal actually 2 winters ago. And we had started working with BioMusic. My intention was to stay with the non-communicative population. And I had so many people approach me and say, "Have you thought of using BioMusic for X, Y, Z?" And a number, from anything. Have you thought about using BioMusic for improving meditation? Have you thought about using BioMusic to train athletes to be able to tune into themselves better? But one of the ones that kept on coming up was, have you thought about using BioMusic for individuals with autism? And I did not have any experience with autism at this point, and I would always say, well, tell me how you see it being useful. And over again, the chorus was, well, if it can allow you to tune into your emotional state, what a cool tool that would be for individuals with autism to be able to tune into their own selves, and for caregivers to be able to tune into them to see if they're distressed, if they're anxious. But one of the things I did not want to do with this technology was to come in and impose the technology on individuals, saying, here is this technology, here is how you will use it. So instead of doing this, we ran a workshop 2 years ago where we invited individuals with autism, their caregivers, their educators, individuals who make policy of individuals with autism, to all come together and envision together how we could use this technology to benefit that particular population. And part of this discussion, we had a very productive 3-day workshop, but part of this discussion needed to be grounded in the reality of BioMusic technology. I've given you a bit of an overview. It's actually quite complex when you get into the guts of it. And we needed everyone to be able to understand how complex the algorithms were, what exactly were the factors that we were working with. So we ended up creating an encounter with BioMusic through art. we had these individuals walk through the Musée des Beaux-Arts wearing BioMusic in small groups and experience what it was like to look at art while your reactions were being broadcast in real time. So if you were looking at a piece that you found embarrassing and you didn't want your partners to know that you found it embarrassing, your music would give you away. And if you were looking at, if you were, for example, we had one participant who was walking down the stairs and she couldn't see very well. Her music went crazy, and her two partners, she wasn't saying anything. Her two partners went to her and immediately said, "Are you okay? Do you need help?" It really revealed a lot. And so just having that firsthand experience of being able to have your internal state broadcast to other people, that was one of the most powerful things that we could do to bring people in on the conversation about how we should develop this technology. The other thing that we did was we had a dancer dance to her BioMusic, generated in real time. This is the video I want to show you now. So we invited a professional dancer to wear the sensor on her finger and to move it wasn't pre-choreographed. She was moving as she felt in the moment, but to put herself in different emotional states as she was moving. And the juxtaposition between some of her movements, so the stillness of her movements and the type of music that was being generated, again, gave us some quite privileged insight to what was going on. And we created a really cool artistic moment. I'm just going to give you the dance was about 20 minutes. I'm going to give you a 30-second snippet of what that dance looked like. Oh, sorry, I'm going to just, I'm going to get back to my video. Okay. I think my PowerPoint has decided not to cooperate. And that's my lab Slack account, so they're developing BioMusic as we speak. Okay, I'm going to give my computer a chance to recover from this, because I think that I've asked it to do something it doesn't want to do. And while I will show you the dance, like we'll get this, if I need to reboot the computer, I'll reboot the computer and show you the dance at the end. But it's an example of how how we were able to use BioMusic to create a really unique form of art, and how that art was able to give people a sense of what the technology was actually able to do. So moving forward from this, we actually had a number of individuals with autism participating in this workshop. And after they said, well, this is really cool, we want to keep on working with you. And one of those groups was a not-for-profit organization here in Montreal called Spectrum Productions. Spectrum is an audio-visual company who does AV recordings of different events, and they provide programming for and exclusively employ individuals on the autism spectrum. And so they said, we would be really interested in having BioMusic here in our workshop. So last winter, we ran a series of 5 workshops with them. Their expertise is in audio design and sound design, and we thought, well, this is perfect. We can get them to design the outputs of BioMusic, because right at that point, really, we had the classical music, and aside from this enthusiast over here, not very many people wanted to listen to classical music all the time, especially teenage boys who did not like my sonification, to be frank. So I said, that's fine. I'll give you the tools, and you guys can design the types of sounds that you want to listen to. So we ran a series of 5 workshops with these individuals in Spectrum Productions in their space. And they ended up designing a number of different sonifications for BioMusic, which are now implemented into the software that we're distributing to our developers. I'm going to just kill my program here and bring it up without showing you the dance, because clearly that made my computer very angry. Okay, so skipping the dance, I'm going to come back to this participatory design. It wants to play for you. It really does. Okay, here we go. So this is just a shot from the workshops that we had. I'm going to give you an example of how we taught. I'm just going to show you, hopefully, show you another video that gives you an example of how we taught these individuals about biomusic. This is my postdoc, Florian Grand, who is teaching individuals to look at their signals. We have a prototypical sonification, so a prototypical mapping between the signals and the output, and he's trying to show them the connection between their bodily responses and the sounds that are being produced. So this is Florian's explanation of biomusic.
Maybe you want to just try to touch your hair again, and then we should see how this graph is going up.
When I'm breathing in, it's like it's getting, well, it's more, how do I put this? It goes at a faster pace. But when I breathe out, it becomes slower.
A bit over there.
Okay.
So this is
Just a little arrow here.
if you hear that, would you feel like your heart goes faster?
Yeah.
Maybe if you want to touch your forehead a little bit.
So you see that link being made. If you touch your forehead, you actually generate an electrodermal reaction. He heard the bling. He's like, oh yeah, that was the sound. That was something that I did. That's the connection. That's the feeling that caused that sound. So we had them recognize the connection between the sounds that were being produced and their body, and then we asked them to create sonifications for us. So we came with a couple of examples of what biomusic could sound like. Florian decided that classical music was not the way to go. He decided that he wanted to be out in nature, perhaps because his supervisor stresses him out a lot, and he wanted a water soundscape. So this was Florian's example of what biomusic, his version of biomusic should sound like. The water is controlled by the heart. The birds indicate an electrodermal reaction. The different types of birds, if you listen carefully, the different types of birds map onto different types of emotional reactions. That was his version of what biomusic should sound like. Another one that came up. This is tablas, an Indian drum. And I'm going to pause that because I hear the birds singing at the same time as the tablas, and that's not what I wanted to do. So I want you to give a clean listen to the recordings that the participants made for me. So this was one participant with autism who decided this was her ideal soundscape. When she listened to her body, this was what she wanted to listen to. Can you figure out what it is? It's a cat, exactly. It's her cat purring. She recorded her cat purring, and she recorded her cat meowing. She mapped the cat's purrs. We had software that allowed her to stretch the cat purring frequency based on features of the heart rate. The meows happened when certain reactions were generated, and she tuned in her body by listening to her cat. This is a different participant. who was also happened to be a composer. This was how he wanted to tune into his body. So the rhythmic component related to one of the features of heart rate. And this, for him, gave him really strong insight into his body. It makes me feel like I'm in a video game. And then the last example I'm going to give you, we had so many of these creations, but the last example I'm going to give you was a third participant who also happened to be a composer, and this was his ideal way of listening to his body. So nothing that I would have created, but this was their happy place, and we have taken these sounds and allowed them to become different sound skins in BioMusic, so that you can scroll through while you're listening to your body and figure out what the best way for you to tune into your own body was. So we created a little bit. We created some new sounds. We created some new art. But we wanted to make sure that fed back into the science, back into the technology. So what we ended up doing was we ended up giving these participants their own sonifications with the BioMusic sensor, and we had them go out and experience a bunch of different things. This is one of our participants. We had them walk through an art gallery. We had them go for a metro ride down through Montreal. We brought them to McGill, which was a very interesting experience for them. And we had them listen to their own developed BioMusic as they were having these different experiences. And then we would come back to Spectrum and we would ask them what they learned about their bodies, what they learned about themselves, what they learned about their bodies. And their reactions were so insightful. The reason I have this picture up, this participant was saying that he was standing in between the rooms of two different art galleries. So the one gallery on this side, one gallery on this side, two very different things happening in both galleries. And he was standing on the threshold, and he noticed that the music was really, really intense. So he sat back and said, what's going on? Why is this music sounding so intense? And he said, I'm overwhelmed with information. And he took a step into the next room, turned away, turned his back to the first room, and the music calmed down. So he was able to use it to self-regulate. He was able to use it to gain insight into his emotional state that he didn't have otherwise. And that sensitivity allowed him to get a better sense of what the technology could do for him. So we took these things, we fed it back to the original population. This is one I've continued to work with individuals with complex disabilities. This is one of the participants in our studies who's wearing the BioMusic sensor. And his parents listened to the BioMusic for 2 weeks, kind of keeping it on extended play, and are looking to find correlations between the changes that they hear and what's going on outside in his environment. So I wanted to leave time for questions. So I didn't want to talk for the whole hour. I just wanted to wrap up with two points. I wanted to just tip my hat to the Convergence Initiative, because the ability to bring science and art together, to have not just science creating art and art informing science, but the two really working in a synergistic cycle, so that one feeds the other, and then the other one informs and creates something completely different in the first. That, I think, is where a lot of the creative potential, a lot of the really interesting ideas, a lot of the groundbreaking work that we can do, that's the world I think that it can exist in. And I'm so excited that Convergence exists to highlight this opportunity in this interdisciplinary field. I also wanted to put a little bit of a plug out there. If you wanted to experience BioMusic, your own BioMusic, there is an exhibit at the Montreal Science Centre where we have BioMusic built into one of their exhibit booths. We present you with a number of different videos and that are meant to induce different emotions. We record your physiological signals and we show you what your biomusic sounds like in response to these different videos. You also would, if you happen to go here, you would be participating in my study, because I'm trying to collect as many normative emotional physiological reactions as I can to train a machine learning algorithm. So come and visit the Science Centre and feed into my study, please. And I also wanted to make sure that I took time to say a big thank you. A lot of the work that I've done here is directly a result of my wonderful lab. Florian Grand, who's pictured there, has done a lot of the sonification work, ran the workshop with Spectrum. I also work with an art historian named Tamar Tembeck, who has been fantastic in driving this forward and recognizing the artistic value of what we're doing. Rose Moto and Ariel are two ethnographers who have been working with me to document the effect of biomusic on the individuals that we give them to. And of course, my collaborators at Spectrum Production, who have been so generous at sharing their insights, allowing me to share the results of the workshop with you today, and Shirk, who funded that particular collaboration. So I think we have about 10 minutes left for questions, and I'm happy to answer anything that you might have. Thank you. Yes.
So I see that your population that you study seems to be quite disparate. The working spectrum production very, very high functioning, and the ones that are at home short
I think you can use the microphone.
Oh, this one? It's okay. Okay, sorry. So the populations you've studied are very disparate, very, very high functioning in spectrum productions, and the children at Holland Bloorview who are nonverbal, completely nonverbal. And do you see a potential for the autistic population that are in the middle, especially adults, because they suffer increasing anxiety as they age, and the behavior becomes more difficult to manage as they're larger and stronger, and there seems to be nothing available to manage this for caregivers, and so would you see a possibility that you could make tremendous impact?
Absolutely. One of the populations that we work with that I didn't mention in my presentation are individuals with dementia, who have a lot of anxiety, that they can't necessarily express, and we work with their caregivers to have them give them the ability to tune into what's going on in the individual dementia's inner world. So I see parallels with that population as well.
Yes. Okay. Wait. To me specifically, it's close to my heart, is that once they're no longer in the pediatric system and you're in the cliff or fall off the cliff, and there is nothing in terms of support and nothing in terms of even mental health, very little options for caregivers, growing number, because it's really the first generation of parents keeping their kids and dealing with this, and there are very, very few answers out there. So yeah, dementia, yes, it's for seniors, yes. But in terms of anxiety, because of the very, very difficult behavior that affects families, and I'm just saying, yeah, there's a huge potential there. Please address.
Thank you.
The parents.
Thank you for the suggestion. Yes.
Thank you. That was a really great talk. I have two fairly quick questions. One is, how far along are you? You mentioned briefly that you're trying to code or see which responses are negative emotionally and which are positive. And so I was wondering, especially considering that it started with looking at whether the clowns were invoking fear, how far along you are in terms of that. And the second is how much the music itself ends up becoming a stimulus. Does that cause feedback into the music?
So your first question, with people who can tell us what they're feeling, we're pretty good. You know, we can, if you can tell us me what you're feeling, and I can train a classifier on your particular body with your particular report, we're pretty good at being able to tell not just positive, negative, but is this frustration, is this anxiety, is this sadness? Like we have a pretty good classification accuracy. With individuals who can't self-report. So in just machine learning world, we don't have the gold standard label to be able to train the classifier. It's a lot harder. So one of the things that we struggle with is you don't want to impose emotions on someone who might not be feeling those particular emotions. So we're taking a very conservative approach. We're saying, is this stimulated or not stimulated? Is it potentially positive? Is it potentially negative? And not trying to put a strong label onto it until we have more information. Your second question, does the music affect? Absolutely. I have a system, a BioMusic system here in my, I apologize. I have a BioMusic system here in my bag, and I'm not presenting with it on because the music affects me. I hear my music, I know that you will know that I'm getting anxious if you listen to my music. It's very obvious, and I'm trying to keep a calm face. The music gives me away, then I get embarrassed, the music gets even worse, and it's just a bad situation all around. So yes, it does affect it. Yes.
Thanks for the great talk. I'm wondering if any parts of the code are open source.
Right now, we're developing, so we have two, I'm going to give a very technical answer. We have two repositories, code repositories in lab. We work with GitHub and we work with Bitbucket. Our EEG code is on GitHub, which is open source. Our BioMusic code is in Bitbucket, which is closed because we are partnering with a company in Montreal and we have IP agreements with them. The eventual goal is to, of course, make this open source, but because we have these IP contracts in place, it's closed for now.
Okay, thanks.
Hi. Have you ever considered to use virtual reality to recreate stimulation and direct also simulations as well?
That would be very interesting. Right now, the stimulus that I've used have come to the bedside, like the therapeutic clowns, or we've just brought people out into different situations. But if we were working with, for example, people with high anxiety, and we didn't necessarily want to bring them onto the metro, if we knew that the metro was what scared them, that would be a fantastic option. Yeah. Yes.
So hi, thank you for your presentation. I had a couple questions. The first was, I know you were saying that you were testing the reactions of caregivers, but I was wondering if you ever played the biomusic of caregivers to people that were non-communicative. And my second one was, as an artist, how can we get involved with you, or like how does that work? Are you open for collaborations at all?
So I'll answer the second question first. Yes. Yes, absolutely. I love my collaboration with artists. I love working with composers, with dancers, with artists, to be able to move this forward. So come find me afterwards, and I'll give you my contact information. The first, not deliberately. So do we expose the non-communicative individuals to music from the caregivers? We always get the caregiver to try out the biomusic, because sometimes it's hard to figure out what the cause and effect is between the music that you're hearing and what's going on inside someone else's body. So we always get the caregivers to try out biomusic first. And we get them to do a number of exercises that calm them down, that stimulate them, get them to do a deep breathing exercise. So in this, and they're always in earshot of the individual who is non-responsive. So in that sense, in the training sense, yes, but we've never said, what happens if we play biomusic for this, for you? Yeah, it's an interesting question. Yes.
Thank you so much for the presentation. Actually, I have a question. It seems like it's based on the biomusic generated from the autonomic nervous system. Have you guys ever tried this on patients who on coma, unconscious? I was just wondering if this music are actually has to be generated from, has to be correlated with emotion changes, or it can be just from the physical response, even for those patients in coma, with coma.
So I suspect that you are more interested in patients in vegetative state rather than patients in coma. Coma, you are asleep, you are out, you're not conscious, and there's no there's no changes in your body that are meaningful when you're in coma. In a vegetative state, or what was now called unresponsive wakefulness syndrome, people's eyes are open, but we don't know whether they're aware or not. This actually is the other element of my research. We use EEG to track the brainwaves associated with consciousness, functional connectivity, graph network properties associated with consciousness. And we've started sonifying those because those are a much stronger marker of whether someone's aware or not. The biomusic in these cases does not change very much because these individuals' autonomic systems are so repressed at this point. So we move more towards sonifying their EEG rather than sonifying their autonomic nervous system. And then once we've established that they're conscious, they're aware, they're reacting, then we move on to biomusic.
Thank you, that's very cool.
Sorry, yes.
Hi, yeah, very great talk. I have two questions. During the talk, most of the talk was about applications of biomusic to patient populations, but would you see this product being released to the general public as well?
Well, our goal is to make it available on the App Store, and I'm hoping in a few years will be publicly available on the App Store. And when we have great fun with this in the lab. We play with it. My students kind of try to ask each other questions to embarrass the other person, and you can hear the answer through the music. It can be used as a game. It can be used as a toy. People use it as meditation sort of training for them. So I see lots of applications for the general public. And your second question, yeah.
Second question. So I'm also a classically trained pianist. I was wondering, what was your favorite composer, if you had a favorite piece?
Just before the talk, I was playing Beethoven. So I would say Beethoven.
Thank you.
Hi, thanks for the great talk. It's really cool stuff. I'm just wondering if you've tried inverting the output ever. So playing a sound that the biomusic would make when the person's calm, when they get more anxious, and if that can potentially affect their anxiety responses or their autonomic responses.
This was a common suggestion from the workshop that we did at Spectrum. They said, in some cases it's very nice to know that I'm getting anxious, but if the algorithm knows I'm getting anxious, I don't want to hear anxious music. I want to hear calm music so that I calm myself down. So there was an active debate about whether we should be creating musical output, sonified states that represented the actual state of the individual, or whether we should be doing a more therapeutic approach and sort of trying to shift the state of that particular individual. I see applications for both. Yes.
I'm wondering what sort of counseling goes to the families of the people using biomusic so that we avoid this overinterpretation or over-labeling of the music that's output.
That's a great question. So right now we have families who are co-developers with us. We give them the biomusic system for 2 weeks at most. We come up to their houses. We train them for an hour on we give them a manual. We train them for an hour on what they can use the music for, what they can't use the music for, how to interpret the music. We have them wear it themselves, and we tell them about the interpretations. And then we come back after a week or two, and we interview them about their experiences. And in this interview, in this follow-up interview, we're getting suggestions for the next iteration of biomusic, and we go back to the lab, we make the changes, and we bring the system back to them. But we also talk to them about what is a reasonable interpretation of what they've heard and what is not at that point. So we keep the families quite closely looped into the development.
Here, I would like to thank you. So I would like to actually, guys, invite you for a cocktail so we can all talk. You can continue talking with Stefanie, but we have food and drinks outside. I think all of you probably got a ticket or two. So while we don't go there, we thank you now. So
Thank you, Christian. We'll see you all outside.